Okay, let's jump right into the space weather explainer because right now, as we speak on July 22nd, 2026, there is a massive wave of energy actively washing over our planet. It's completely silent and it's totally invisible to the naked eye during the day. Yet this invisible force has the power to light up the night sky in ways you wouldn't believe, and it can even mess with the technology we rely on every single day. It's this absolutely fascinating intersection where deep space astrophysics literally crashes into our own earthly backyard. So, the big question we're tackling today is this. Could a stunning Aurora Borealis display be visible tonight across parts of Canada and the United States? A lot of us think of the Northern Lights as this rare thing you have to travel all the way to the Arctic Circle to see. But under the right conditions, the cosmos actually brings the show directly to us. Today, we're going to break down exactly what those conditions are, where all this energy is coming from, and how you can maximize your chances of catching an incredible phenomenon tonight. Let's start with Section 1, the cosmic light show, and this incoming G1 storm. Now, space weather terminology can sound a bit intimidating at first, but we're basically just talking about the weather, except instead of rain, we're measuring charged particles. Tonight's G1 storm actually isn't caused by a massive coronal mass ejection. Those giant, violent explosions of plasma you always see in sci-fi movies? Yeah, it's not that. Instead, we're experiencing a stream of high-speed solar wind. Think of it like a persistent, fast-moving cosmic jet stream that's just relentlessly colliding with Earth's protective magnetic bubble. And there is a very specific number you need to know tonight: 5.33. NOAA, the National Oceanic and Atmospheric Administration, is predicting the planetary Chaos Index will reach exactly that level. The Chaos Index is essentially a scale from 0 to 9 that measures geomagnetic disruption. A normal quiet day is usually just a 1 or a 2, so hitting a 5.33 is a pretty big deal. It means the storm is strong enough to grab the Aurora Borealis and push it much farther south than its usual Arctic home. Moving on to Section 2, the Sun's powerhouse region, known as AR 4493. To really understand why our planetary index is spiking like this, we have to travel 93 million miles away to the surface of the sun. Earth Sky recently described a brand new sunspot region as a powerhouse newcomer that arrived with a bang, and they hit the nail on the head. Just a few days ago, the sun was actually pretty quiet. There was a lull in activity. Then, almost out of nowhere, this highly active region rapidly bubbled up from the depths of the sun, completely shattering that quiet period. I want you to just think about the scale of this for a second. Contrast the quiet, intimate act of stargazing in your backyard with the immense, chaotic reality of this solar engine. We're talking about a gigantic, 100,000-kilometer-wide ring structure sitting right on the surface of our star. To put that sheer size into perspective, you could line up almost 8 entire Earths across the width of just this one single sunspot. It's literally a bubbling, churning cauldron of magnetic energy. In the volume of activity pumping out of this one spot is just staggering. In a single 24-hour window, AR 4493 fired off 23 of the sun's 24 total solar flares for that day. 23! And these weren't just minor little sparks either. They included incredibly powerful M3.6 and M1.7 class flares. This thing essentially turned into a machine gun of solar energy, single-handedly driving the entire global flare activity metric. The reason AR 4493 is acting so hyperactive comes down to its magnetic structure. It boasts what astrophysicists call a beta-gamma-delta configuration. Now, you definitely don't need a PhD to understand why that matters. You just need to know it is the absolute most complex, tangled, and unstable magnetic state a sunspot can possibly have. Because those magnetic field lines are so twisted up, they act like tightly coiled springs ready to snap. That means this region almost certainly has plenty more massive flares in store for us. But here's a really fascinating twist. While that massive sunspot is providing all the spectacular flares and fireworks, tonight's specific aurora forecast is actually being driven by something else entirely, a negative polarity corona hole. This is a dark, lower-density region in the sun's outer atmosphere, where the magnetic field essentially opens up into space like a giant valve. It's aggressively blowing that stream of fast solar wind directly toward Earth. So we're basically looking at a perfect storm of solar phenomena happening all at once. Let's dive into Section 3, forecasting the solar wind and the million-mile warning. You might be wondering, how do we even know an aurora's coming before it lights up our sky? The answer is sitting an astounding 1 million miles away. To give us a 30 to 90-minute warning before a solar storm hits, forecasters rely on a satellite positioned at the L1 orbit point. That's a gravitational sweet spot directly between us and the sun, a million miles upstream from Earth. Out there, sensitive instruments measure the solar wind velocity and the interplanetary magnetic field. They're essentially tasting the storm before it ever crashes onto our shores. All of that crucial data captured a million miles away is immediately beamed back to Earth and fed into something called the ovation model. And this isn't just a static piece of software. It's an advanced algorithm that has evolved over more than a decade. From its first creation in 2009 to a real-time NOAA version in 2011 and a major upgrade in 2013 to handle those really massive storms. Today, we rely on the highly operational Ovation 2020 model. It takes that raw solar wind data and instantly calculates the precise location and intensity of the auroral oval. That brings us to Section 4, Hidden Impacts on Earth. Because as it turns out, this is about way more than just a light show. While the northern lights are absolutely breathtaking, these solar storms also carry hidden threats to our modern way of life. Even a minor G1 storm and the associated R1 radio blackouts can actually degrade high-frequency radio communications, especially on the sunlit side of the Earth. It can cause brief hiccups and errors in GPS navigation signals, meaning your phone's map app might get a little confused for a minute. It can even induce rogue electrical currents right in the ground that put extra stress on our electric power grids. It is a very real, vivid reminder that we live inside the atmosphere of an active star. All right, let's wrap things up with Section 5, your ultimate viewing guide for catching the aurora tonight. Let's ground all this complex astrophysics into practical reality so you can actually witness the results. If the skies stay clear of clouds tonight, folks across much of Canada are in for an absolute treat. But what's really exciting is that residents in the northern U.S. states right along the border have a fantastic opportunity too. We're talking Washington, Idaho, Montana, North Dakota, Minnesota, Wisconsin, Michigan, and all the way over to Maine, Vermont, and New Hampshire. The expanded auroral oval is reaching right down into these latitudes. But hey, you can't just step out onto a brightly lit city street and expect to see the cosmos. To maximize your chances, you have to follow 3 simple rules. First, you absolutely must escape the city light pollution. Go find a dark rural area or a state park. Second, orient yourself and face the northern horizon, because the lights will likely be low in that direction, not directly above your head. And third, and this is crucial, be patient. Put your phone screen away and let your eyes completely adjust to the darkness for at least 20 minutes. Actually, speaking of your phone, our everyday tech can be an incredible scientific tool for this. You can often use your smartphone to see the aurora way better than your own eyes can. If you put your phone on a tripod or just lean it against something sturdy and use the long exposure night mode, the camera sensor gathers light over several seconds. This simple trick will often reveal vibrant swirling greens and purples on your screen that your unaided eye might just see as a faint, colorless haze. It's a real game changer. It really is quite humbling when you put the whole shebang together. From a chaotic 100,000-kilometer-wide sunspot to a stream of invisible plasma passing a sensor a million miles away in deep space, all culminating in a glowing, dancing sky above your local park. As you look up tonight, armed with the knowledge from this explainer, you really have to wonder, what other silent, powerful forces from the deep cosmos are washing over our planet completely unseen right now? Stay curious, everyone, and keep looking up.